So, we have been factoring things out, yes? Okay. Sometimes we get to a problem where we can't figure out what factors make something happen. Okay? And we just write not factorable, which technically isn't true because there's other ways to solve it.
No.
Okay? It might not be factorable in that scenario, but we can use quadratic formula to solve. We could use completing the square to solve. We can use lots of different things to start solving stuff that is not factorable. Okay? So if I have an equation like this, it says x squared minus 8x plus 16 equals 25. Okay? If I want to solve this, okay, I am going to have to do something called completing the square. Here's what I want to do. I want to turn it into something where I can take the square root of both sides and get an answer. Now, look at just x squared minus 8x plus 16. What do you know about that problem right there?
4 plus 4 and 4 times 4.
Yeah. 4 plus 4 and 4 times.
Yeah. X minus 4, x minus 4.
Okay, so you have x minus 4 squared because it is a perfect square trinomial.
Yeah.
Okay, so I could set this up and say x minus 4 squared equals 25. Can I solve from there?
Yeah.
Yes, take the square root. Because here's the deal. If I originally had subtracted 25 from both sides and set it equal to 0, I'm going to get something that's not factorable.
Oh.
Okay? But if I can recognize that that is a perfect square trinomial and change it, I can take the square root of both sides and start to solve. That's why we have to recognize our special things going on. Okay? So from here, I would take the square root, yes? And I would get x minus 4 equals what? Plus 4 minus 5, which some of you forgot to do on your quiz yesterday and took points off. You add 4 to both sides, so x equals what or what? 9 or negative 1. Okay. So by completing the square, I can solve. Now, that square was already completed for us. We're going to talk about what happens when I don't have things in there and I have to complete the square myself. So this was solving a quadratic equation by finding the square roots. Now we're going to look at how do you solve a quadratic equation when you're missing a portion of it.
Wait, hold on.
Okay.
Where did negative 1 come from?
Because negative 5 plus 4 is negative 1.
I have a question.
You have 5 plus 4 and you have negative 5 plus 4.
Oh, okay.
I have a question.
Okay.
Did you take 2 out of both?
When you take the square root of something, it gets rid of the square.
So you took the square root of 16.
No, I took the square root of x minus 4 squared. I took this because it's a perfect square trinomial and changed it into x minus 4 squared.
How is 8 a perfect square?
It's a perfect square trinomial. It's not a perfect square. The beginning and the end of this are perfect squares. That's what makes it a perfect square
So you just
trinomial.
ignore the 8 altogether?
No, it gets an 8 when I factor this out.
How so?
Because 4 plus 4 is
Because you have this. X minus 4 times x minus 4.
Oh, okay.
Okay. Okay. So that is a pretty simple one. If you can recognize from the beginning, hey, it's a perfect square trinomial, I can change it, rearrange it, solve it.
Wasn't nothing about that simple.
Okay?
Wait, no, I have another question.
Okay.
So 4, so it's plus or minus 5, right?
Yes.
And that's a positive 4. So wouldn't it be positive? Oh, okay. I see what you did here.
Okay. So, completing the square. Perfect squares. Okay, the first one we went over, the trinomial x squared minus 8x plus 16 is a perfect square because it equals x minus 4 squared. Okay, sometimes we need to add a term to the expression x squared plus bx to make it a perfect square. Cameron's excited. Okay, this is called completing the square. So we're going to add a term to stuff when it's only in x squared plus bx form. We're going to add something to it so that we can make it a perfect square so that we can solve. It'll make it easier in the long run to solve that way. Okay? To complete the square for the expression x squared plus bx, this is what you do. You take whatever b is, you divide it by 2. Okay, that's what this is saying right here. To complete the square of this, you take whatever b is, you divide it by 2, and you square it. Now, this is the tricky part. If you have something like x squared, okay, let's say plus 4x equals 6, okay? I'm going to take half of 4, which is, square it, okay? But whatever I add to one side, when I complete the square on this side, I have to add it to the other side of the equation as well, if there is something over there, okay? Because on some of your homework questions, they're just gonna ask you to simply complete the square. It's not set equal to anything. But if it is set equal, I have to add it to both sides of the equation. Because I'm changing what is happening here, I have to change what happens on the other side. Okay? Because then from here, I can set up what we just did. X plus 2 squared equals 10, and you can solve from there.
Oh.
Okay? That's what our end game is to get to that step so that we can solve.
Why can't they just be-
I don't get all those little boxes down.
Yes, I find them confusing, don't stress about those.
I don't get it.
If you understand that you should take half of b and square it and add it to both sides, you will do the equation fine,
Oh.
Wow, that's
okay?
a lot more.
The little boxes are showing me this. Well, maybe, I don't know if I have one. Yes, they do.
Yeah.
Okay, the little boxes are showing me this. They're basically telling me that I have a square, the first hole, okay? Then I have portions that can make it up. So like 3 of these would fit in there. That's like your middle term, okay? Your last term would be
Bro, what?
What is square roots?
your last term would have
That don't make it later, that's. confusing.
9 of these in there. You get what I'm saying? So what happens is, I took the middle term, cut it in half, and I squared it to get the last term, which is what's on the outside.
She made a construction paper.
Okay.
I'm not gonna listen to that because that was really confusing. Just gonna.
Okay. So some of your questions tonight are gonna look like this, where it says x squared plus 16x plus c, okay? When it has it that way, it literally just wants you to tell me what c would be if you complete the square for that trinomial. Okay? How would I complete the square for that
You
trinomial?
would, take the square root of x squared and 16x.
No.
64.
Oh my god.
Okay, so what do I do, Brady, to get that?
16 divided by 2.
Yes. I take 16, I divide by 2, I get 8, I square it, and c equals 64. So some of your homework problems are gonna be that simple. Okay? You're completing the square just to finish the perfect square trinomial.
So what does it mean, write the expression as a square of the binomial?
Then write the expression as a square of the
Oh,
binomial.
so to get c, all I have to do is b divided by 2 squared?
Yes, correct.
Okay. That
Okay?
makes sense.
So then when it says to write it as a, expression of the square of a binomial, what does that mean I need to change it into?
Standard form.
Nope, standard form is not the square of a binomial.
So there's that one.
If it says square of a binomial, what do you think should probably be in there at some point?
Oh,
A
you have
square.
to,
So I need to change it to
oh, that's not
that form, that's the square of a binomial. Okay, so it was asking for 2 parts, it was asking for what is c, and then write it into the square of a binomial, which is just x plus 8 squared in this case. Okay. The next one says, solve x squared minus 12x plus 4 by completing the square. So it's telling you, don't factor this, complete the square. How would you complete the square on this? There's already a c there, what do I need to do? I need to make it into a perfect square trinomial. Does that 4 make it a perfect square trinomial?
Yes. Because it's a perfect square.
No.
No, because 4 and 1 don't add to give me -12, so it's not a perfect square trinomial. And I can't
No
factor
solution.
that. No, there is a solution. What? I subtract the 4. If I subtract the 4 to the other side of the equation, I get x squared minus 12x plus something equals -4. This is where I'm going to complete my square. How do I complete my square?
-12
So just take 12, just take b, don't worry about the
36.
negative.
36.
divided by,
Yeah. 12 divided by 2, which is 6, and then 6 squared, which is, if I put that 36 there, what else do I have to do? Over here. So now, I'm going to write this so that it says x minus 6 squared equals 32.
Oh, I
because
get it.
-4.
I get it now.
Okay? From there, what do I need to do?
Square root of both sides.
Square root of both sides. So x minus 6 equals plus or minus, how does 32 break down?
4 times 8,
4 times 8, so 4 radical 2?
2 times 16.
Well, 32, you said 4 and 8, right? And then 8 is 4 and 2, so 4 radical 2, correct? Okay, so then I get plus or minus 4 radical 2. Now what do I have to do? Add 6. So you should get x equals 6 plus or minus 4 radical
I have a question.
2.
Do I put the smaller number in the radical? Is that how it works?
You put whatever number is left over that's not a pair back into the radical.
What?
If it's not a pair, you can take it out of the radical.
So wait, it was 4 and 8.
So how did you get 4
So,
radical
yeah.
2?
How do you get
Because
4?
look, 32, 4 and 8, 8 is 4 and 2, there's a pair.
Hey.
How did that work?
It's called a factor tree.
No, but how did you do that?
I divided, what do you mean? If they're a
Why
pair,
did
they
they-
come outside of the radical. Period. You have to have a
Then
pair.
why isn't it 4 radical 4 if you circle it?
It's not 4 radical 4. I circled 4 because they're a pair, so I can take that out of the radical. The only thing left is a 2, so it stays inside.
Oh boy, that shoulder looked
I
really
didn't
good.
do that.
Okay. Here's what we're gonna do. I'm gonna stop there tonight because we're going to practice with just leading coefficients of 1. Tomorrow we will practice with leading coefficients that are not 1.
Too bad we won't be here.
You shouldn't have told her that,
Friday.
so she would have thought.
Oh. Well, I was letting her know, cause you know how every
Friday. Friday we will practice with
With
leading
Connor.
coefficients that are not 1.
And
You need to get used to this
Oh, I know.
before you get used to a leading coefficient that's not
I
1.
don't know.